Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Ring strain arises primarily from angle strain, deviation of bond angles from ideal values, and, to a lesser extent, torsional strain. Smaller rings have greater angle strain because the interior angles of the ring deviate more from the ideal sp3-109.5 degree or sp2-120 degree bond angles. Moving on to the next step. 3-membered rings, 4-membered rings, 5-membered rings, 6-membered rings, nearly strain-free. Moving on to the next step. A. Delta-lactone is a 6-membered ring, essentially strain-free, chair conformation available. B. Gamma-lactone is a 5-membered ring, slightly strained but relatively stable. 5-membered rings adopt envelope conformations with modest angle strain. C. Beta-lactone is a 4-membered ring, highly strained due to severe angle strain, interior angles forced to ~90 degree versus ideal ~109.5 degree for sp3 and ~120 degree for sp2 carbonyl-carbon, making it the most reactive and strained among the options. D. Delta-lactam is a 6-membered ring, essentially strain-free, similar to A. And for the final step, options A and D are 6-membered rings with negligible ring strain. Option B is a 5-membered ring with low ring strain. Only option C, the 4-membered beta-lactone, experiences significant angle strain. The beta-lactone, 4-membered cyclic ester, in option C, is the most highly strained ring among the choices given. Therefore, the correct answer is C. Therefore, the correct answer is option C.